Hello, it's Super Easy Math. Hope you are fine and doing well. In this video, we'll talk about domain of definition, so let's get started. We have said before that a function is a machine that take input x and produce an output f of x. But what is a domain? Suppose that f of x equal to 1 over x. Let's take some values of x and see what will be the output. If x equal to 1, so f of 1 equal to 1 over 1 equal to 1. If x equal to, f of 2 equal to 1 over 2. But what if x equal to 0? In this case, f of 0 equal to 1 over 0. 1 over 0 is undefined. So in this case, we say that 0 is outside the domain because it produces an undefined output. We have nothing in math called 1 over 0. So 0 is not in the domain. So domain of f is x belong to real number r except 0. So x cannot be 0. So domain can be defined as a set of all input values that make the function defined. Let's take some few functions and try to find their domains. The first one, y equal radical to x plus 4. So just ask yourself, is there any number that x cannot be? Well, we know that any number below the radical should be positive. So 2x plus 4 should be greater than or equal to 0. If we want to find the value of x, subtract minus 4 on both sides. So 2x is greater than minus 4, divide by 2. So x is greater or equal than minus 2. So for this function to be defined, x should be greater than or equal to minus 2. This means that domain of definition should be from minus 2 to plus infinity. On the x-axis, suppose that this is 0, this is minus 1, and this is minus 2. So for the function to be defined, x should be greater than minus 2. This means all these values. Another example, g of x equal to x cubed plus 5x plus 2. So this is a polynomial, and because it's a polynomial, then its domain is immediately minus infinity plus infinity. So any real number is in the domain. Moreover, if it's a quadratic equation, for example x squared plus 2x plus 5, then its domain is also minus infinity plus infinity. A linear equation also, for example y equal 3x plus 5 or plus 1, this is also had the domain minus infinity plus infinity. So all the values of x are defined. Another example, of x equal to radical x minus 1. So for this function to be defined, the numbers below the radical or the square root should be positive. So we say x minus 1 greater than or equal to 0. To find x, add 1 on both sides. So x should be greater than or equal to 1. So suppose that this is a number line. Here is 0 and here is 1. So all the numbers greater than or equal to 1 are in the domain. We can say that the domain is from 1 to plus infinity. So all these numbers here in this area. Another example, find the domain and range. Domain only, we'll talk about range in the next video. So f of x equal to 1 over 2x minus 5. This is a rational function, so the denominator should be different from 0 because 1 over 0 is not defined. So 2x minus 5 should be different from 0. To find x, we will add 5 on both sides. So 2x it does not equal to 5. Divide by 2. So x should not equal to 5 over 2. So the domain of definition is R, all real number except 5 over 2. Or we can say it's minus infinity 5 over 2 excluded, intersection 5 over 2 plus infinity. h of x equal to x over x squared minus 7x plus 10. So the bottom or the denominator should not equal to 0. X squared, so x squared minus 7x plus 10 is not equal to 0. Now we should factorize or write it in the product form. Just find two numbers whose sum is equal to minus 7 and the product equal to plus 10. We have minus 2 and minus 5. If we add them, we will get minus 7, and if we multiply them, we will get plus 10, sorry. So this expression can be written as x minus 2 and x minus 5. Now we can say that x minus 2 is different from 0 and x minus 5 different from 0. So x should be, if we add plus 2 here, should be different from 2, and x should be different from 5. So the domain of definition is all the real number except 2 and 5, or this dash mean except 2 and 5. And the last example, f of x equal radical x minus 1 over x squared minus 9. Here we have two restrictions. Everything below the square root should be positive, so x minus 1 should be greater than or equal to 0, and the denominator or the bottom should be different from 0. So x squared minus 9 is different from 0. If we add 1 on both sides, we will get x greater than or equal to 1. And here, if we factor it, so it's equal to x minus 3 times x plus 3. Now we can say that x minus 3 is different from 0, or x plus 3 is different from 0. So add 3 here, so x is different from 3, or x is different from minus 3. Because x is greater than or equal to 1, then x is for sure not minus 3. So if you wanna plot it, suppose that here is 1, so x should be greater than or equal to 1 except 3. So here it's undefined. We can say that domain is from 1 to 3. 3 is excluded because x is not equal to 3. Intersection 3 to plus infinity. Just pay attention to the bracket. This means that 3 is excluded, it's not in the domain. Hope it's clear. Goodbye.